Here we have another one of our differential equations free response problems. Very intimidating looking graph. I apologize, this portion of this stuff up here, this vertical line through there, is not part of the original graph. It was on my Notability sheet, and I forgot to erase it before I imported it into this app to do this video. So pretend that's not there. I may reference it later though. But this is a really intimidating looking graph. The equation is implicitly defined with x's and y's mixed up. And it's important to realize that it says y is less than or equal to 11. This is a function that wouldn't be, there would be no inherent restriction to y in this thing. It's just, this function's just defined up to 11. So they give us dy dx, they give us the formula for the slope at any point on this thing, and they tell us at point P the x coordinate is 2. So I've got that up there with a question mark in the y, because we don't know what y is at that point. We're going to have to find that out in part of this first part of this problem. So it says write an equation for the tangent line to the graph at point P. So, of course, I've said this many times, we need a point and we need a slope. And the point is going to be 2, comma, like I said, something. So in order to find the y value when x is 2, we're going to need to use our equation. So we're going to plug in 2 for x and get 2 squared equals negative 2 plus y plus 5 cosine of y. So we're going to add 2 to both sides and get 6 equals y plus 5 cosine of y. And that's not an equation we would be able to solve algebraically. So what I'm recommending is we're going to solve this graphically. We're going to use our calculator. So we go to my calculator, and y equals, in y1 I would put y equals 6, and in y2 I'm going to put x plus 5 cosine of x. In other words, because the calculator isn't going to let you use y as your variable, we're just going to call it x for a minute and graph that. Now, to help yourself a little bit, let's set our window up, because y has to be less than 11, and we're looking for the intersection right there, which looks like it's somewhere between 4 and 5. Why don't we set our window, our x min, at 0 and x max at 11. So what that's going to do is give us y equals 6. I'll just draw that as a horizontal line here. And then y equals x, this function, y2, I'll draw that in blue. I don't know, it's going to be some kind of sinusoidal thing, and it's going to go up and down. And it's probably going to cross a few times. As you can see from the graph up here, that's where that vertical line came from. If I draw this blue line for x equals 2, there are several places where it crosses. Well, what we're going to be doing is looking for the one that's the first one, the first positive one. So it would be like this one on this graph. So if you put that into your calculator and you find the intersection, the first intersection occurs at x equals 4.928. Of course, that x, though, is really y. We were using x as the name we had to use it. So the y coordinate is going to be 4.928. So we now have our point, which is 2, 4.928. And now we need our slope. So to get the slope, we have a formula for that right here. So we're just going to plug 2 in for x and 4.928 in for y. So we're going to get 2 times 2 over 1 minus 5 times the sine of 4.928. And we'll get that number, and we'll be ready to go. Rounding appropriately, we get 0.680. So there's our slope. Here's our point, so we can just go to y equal, or I'm sorry, point slope, y minus the y value, 4.928, equals m, which is 0.680, x minus the x value. So there's point slope form, which is sufficient because that's all they're looking for, but we can, if we want to put y by itself, 0.680 x minus 2 plus 4.928. If you feel like distributing the 6.68 in there, go ahead. But that ought to do it for this problem. So pretty straightforward. Write the equation of a tangent line, but with a little bit of a curveball that you got to get a lot of this information off the calculator. Okay, for part B here, find the y-coordinate of each point on the graph where the line tangent to the graph at that point is vertical, and that's key. You need to know that if a tangent line is vertical, that means its slope is undefined. Slope being undefined, dead giveaway, you need the denominator to be 0. That should be, burned into your brain from Algebra 2 and pre-calc. To make something undefined, you make the denominator equal to 0. So we need 1 minus 5 sine y to be 0. So we're just going to set that up algebraically. 1 minus 5 sine y equals 0. And that means we're going to get 5 sine of y equals 1, or the sine of y equals 1/5. Now this is a critical step because some of you might be inclined to use inverse sine and go and say the inverse sine of 1/5 equals your y value. And that's admirable that you remember the inverse sine is a thing that exists. However, inverse sine, remember, is a function that was defined so that it gives you only one solution. In other words, it's going to search on the unit circle for the place where the sine of an angle is equal to 1/5, and it's going to be this angle right here, which is going to be, I don't know, something like 10 degrees, 15 degrees, something like that, maybe 20 degrees. But that's, or which would be like, 0.3 radians or something like that, 0.2 radians. That's great, but that's the only angle it's going to give you. And we want to find all of them. So it's much better to do this graphically. And again, just like we did in the last problem, I'd set up y1 is the sine of x, and y2 is 1/5. And you would go to that graph and set your window up from 0 to 11 again so that you capture all the possible solutions. And of course, between 0 and 11, your sine curve is going to go up and come down. It's back here by 6.28, so it's going to come up and down and then get back somewhere probably around here before it gets to 11. Meanwhile, y equals 1/5 is going to come across like that. So you're going to get several answers. You should get 1, 2, 3, maybe 4 answers just on my rough drawing. But all you do is second calc intersect and find those 4 intersections, and you'll be good to go. So I went to my calculator and found those intersections, and there they are. And that's all it asks. Just find the y-coordinate of each graph where the line tangent is going to be vertical. That's just testing to know if you make sure that if you've got a derivative with a rational expression, you're going to need to make the denominator 0. If it said find all the points where the tangent line is horizontal, that means your slope is 0, and you'd want your numerator to be 0. And of course, that would only be 0 when x is 0. So there you go. There's part B, cruising right along. Okay, it's just about to start the second, or the last part here, part C. And I look back at this, and I got those 4 coordinates, and I flip back to the previous slide to look at the graph again, because I just wanted to kind of take a look at this part C problem. When I looked at the graph, I was like, wait a minute. with y being between 0 and 11, 0 of course being down here, and 11 being way up here, it's pretty clear from the graph that there's 3 places where the tangent line is vertical. And yet we had 4 answers. And I was like, wait a minute. What's wrong with this picture? And I just realized that we really, we solved this equation, y, sine of x equaling 1/5. But remember, that's due to the derivative denominator being 0. Any point that we find, any y-coordinate that we find, remember it has to satisfy the equation here. And if you notice, whenever you see x squared or something squared, you say, okay, that's always going to be positive. And here's what's going to happen. If we were to plug 0.201 in here, you'd have negative 2 plus 0.201, that's going to be about negative 1.8. The cosine of 0.2 is going to be a decent sized fraction, probably somewhere around 0.8 or 0.9 5 times that is going to be a pretty big number, so the thing is going to turn out to be positive, and which can happen. X can get that. So this point down here, that y coordinate there, is this one, 0.201. Likewise, if you plug in 6.8485 in here and in here, you're going to get a positive answer. And if you plug in 9.223, you're going to there and there, you're going to get a positive answer, and you could solve for x. However, if you put in 2.94, what's going to happen is -2 plus 2.94 is going to be 0.94. And if you put a 2.94 in here, that's 2.94 radians, which is going to put you somewhere really close to pi radians, which is going to give you a cosine value around -1. 5 times -1 is going to be negative 5-ish. So this quantity will turn out to be negative when you plug in this number. And getting a negative here means x squared is a negative, which means that can't happen. So we have to toss this guy out as an extraneous solution, because although it satisfies the condition that 1 minus 5 sine y would equal 0, it doesn't fit in the original equation. I honestly don't know. If you left that in there as a solution, my guess is you probably wouldn't get the points. That's pretty tricky. But because the picture, the graph is right there, you can see that there are 3 answers, and these tick marks are there, so you could just look at the graph and tell that that one is not a valid solution. But that's pretty tricky. Now, moving on to part C, find the average value of whatever. As soon as you see that phrase, find the average value of something, that means, if it's find the average value of a function f on the interval from a to b, it's 1 over b minus a, integral from a to b of f of x dx. So there's our template. Because we're trying to find the average value of the x coordinate from y equals 5 to y equals 9, we're going to go, okay, from 5 to 9 is our integral, 1 over 9 minus 5. So it's going to be 1/4 of whatever we get. Our x coordinate, though, it's kind of like saying, okay, well, x equals, what's the function that describes x? Well, if you come up to our original expression here from the original page, x squared equals -2 plus y plus 5 cos y. We can get x. All we have to do is take square roots of both sides. So let's do that. And our integrand will be what x is equal to, which is -2 plus y plus 5 cosine of y with a dy on it. So that is going to be the average value of x between 5 and 9. Be careful putting this in the calculator, but we should be able to spit out the answer. Don't forget to divide. I'm sorry, I have a typo here. I have 9 minus 4 instead of 9 minus 5. I was thinking that the result was going to be 1/4. Let's make sure we get that put in the calculator correctly. Don't forget to divide by 4 or multiply by 1/4, and we'll be good to go. All right, using Math 9 on the calculator, I got 2.550, and that's all she wrote. So there you go, A, B, and C. Nothing too crazy there. A lot of the fundamental ideas, a lot of calculator work to get intersections and stuff. But out of 9 points, this is one I would want my students to be able to bank at least 6 or 7 on. Especially this average value one. That was pretty much laid out there. The only thing you had to do is take square roots of both sides.